On 3 December, an international team of astronomers will announce the most detailed ever catalogue of the stars in a huge swathe of our Milky Way galaxy. The measurements of stellar positions, movement, brightness and colors are in the third early data release from the European Space Agency's Gaia Space Observatory and will be publicly available. Initial findings include the first optical measurement of the acceleration of the Solar System. The data set, and early scientific discoveries, will be presented at a special briefing hosted by the Royal Astronomical Society. Launched in 2013, Gaia operates in an orbit around the so-called Lagrange 2, L2, point, located 1.5 million kilometers behind the Earth in the direction away from the Sun. At L2, the gravitational forces between the Earth and Sun are balanced, so the spacecraft stays in a stable position, allowing long-term essentially unobstructed views of the sky. The primary objective of Gaia is measure stellar distances using the parallax method. In this case, astronomers use the observatory to continuously scan the sky, measuring the apparent change in the positions of stars over time, resulting from the Earth's movement around the Sun. Knowing that tiny shift in the positions of stars allows their distances to be calculated. On Earth, this is made more difficult by the blurring of the Earth's atmosphere, but in space the measurements are only limited by the optics of the telescope. Two previous releases included the positions of 1.6 billion stars. This release brings the total to just under 2 billion stars, whose positions are significantly more accurate than in the earlier data. Gaia also tracks the changing brightness and positions of the stars over time across the line of sight, their so-called proper motion, and by splitting their light into spectra, measures how fast they are moving towards or away from the Sun and assesses their chemical composition. The new data include exceptionally accurate measurements of the 300,000 stars within the closest 326 light-years to the Sun. The researchers use these data to predict how the star background will change in the next 1.6 million years. They also confirm that the Solar System is accelerating in its orbit around the galaxy. This acceleration is gentle, and is what would be expected from a system in a circular orbit. Over a year, the Sun accelerates towards the center of the galaxy by 7 mm per second, compared with its speed along its orbit of about 230 km a second. Gaia data additionally deconstruct the two largest companion galaxies to the Milky Way, the Small and Large Magellanic Clouds, allowing researchers to see their different stellar populations. A dramatic visualization shows these subsets, and the bridge of stars between the two systems. Dr. Floor van Leeuwen of the Institute of Astronomy at the University of Cambridge, and UK Gaia Deepak project manager, comments, Gaia is measuring the distances of hundreds of millions of objects that are many thousands of light-years away, at an accuracy equivalent to measuring the thickness of Ha. These data are one of the backbones of astrophysics, allowing us to forensically analyze our stellar neighborhood, and tackle crucial questions about the origin and future of our galaxy. Gaia will continue gathering data until at least 2022, with a possible mission extension until 2025. The final data releases are expected to yield stellar positions 1.9 times as accurate as those released so far, and proper motions more than 7 times more accurate, in a catalogue of more than 2 billion objects. Story source: materials provided by Royal Astronomical Society. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.